Okay, hello everybody. This is our first video for the class, virtual class, on October 22nd. We are going to be talking about volcanism on the planets. Here, you know me, I like to have black. Volcanism. Okay, we've already talked about tectonism, and volcanism is closely related because it has to do with heat from the inside of the planet in the same way that tectonism does. So with volcanism, that heat rises up from the planet interior. Oh, I'm having issues with my pen. Sorry about that, y'all. Rises up from the planet interior. And that means that the rocks near the surface melt under all of that heat. That rock melts, that turns into what we call magma, and magma flows out of volcanoes or cracks in the surface. We get lava flows, volcanoes, and things like that. So we're going to be talking about those in this section. Okay, so it's sort of like a special form of tectonism. Interior heat comes to the surface, melts the rocks. So let's look at what's happening with volcanoes on all the different terrestrial planets. Just like we've been doing a tour with these other processes, volcanoes are known to be currently on, or in the past occurred on all 4 of our terrestrial planets, so Mercury, Venus, Earth, and Mars. But at the moment, only Earth's volcanoes are known to still erupt or be what we call active. Okay. It is possible that there's activity on Venus, say, but we have not seen active eruptions. Recent maybe, but not active. So only Earth is known to have active volcanoes. Fortunately, they don't erupt too often because they're pretty disruptive when they do. Let's look at the moon. Okay. We don't really think about the moon having volcanoes per se, but it does have volcanism. So we don't see big mountains that erupt like we think of with a volcano, but instead the moon surface has really been changed by lava flows. Okay. These lava flows, instead of coming from big mountains, they came from cracks in the surface. The lava came to the surface, flowed out, and that smoothed the surface and erased some of those early craters. Remember, we said a lot of the craters happened really early, 4 billion years ago. Since then, some places on the moon have been smoothed out by lava. Thin lava that doesn't build up a mountain, but just sort of flows over the surface. These lava flows on the moon have a particular name. They're like the oceans or the seas. Ancient, well, not really ancient, but in the past, people looked at the moon and they saw these dark places on the moon and they thought that they were oceans. So they named them Latin for seas. That's Maria. Mare, singular, Maria, plural, Latin for seas, because early observers of the moon thought it was actually water. These Maria, we now know, are these ancient lava flows. They don't have very many craters. They do have some, but they don't have as many craters as the rest of the surface. So that means that these lava flows came after most of those early craters. Okay. So that's the rest of that. They formed after most of the impacts. And here's a little map here. You might have heard of some of these Maria or mares, the Sea of Serenity. These are some places, Sea of Tranquility places, that the Apollo missions landed because they're nice and smooth and flat, as opposed to the more cratered parts of the moon. So these dark places that kind of make up the face of the man in the moon, you can now know that they are Maria. Okay. Most of these were active about 3 billion years ago. There's some evidence that might have been active maybe 50 or so million years ago, but still a while back. Next up is Mercury. Okay. Mercury, a lot like the moon, Um, it's actually probably more cratered than the moon, but it does have some smooth surfaces from lava flows. We don't see quite as many. Um, and it does have a few what we would actually call volcanoes, although they appear to be inactive. So small mountains that at some point in the past erupted and had lava flows, but today are inactive. Mercury is pretty much all craters going on there, like we've talked about in other classes. Next up is Mars, getting a little more interesting as we move along here. So with Mars, it's sort of a half and half. More than half of the surface is covered with volcanic rocks. So that's different from Earth, for example. Most of the rocks that you see are not from volcanoes. They're just sort of normal composite rocks. But on Mars, half of the surface has lava rocks. Maybe some of y'all have seen obsidian or various types of lava rocks. That's half the surface of Mars. So that means that there were a lot of volcanoes, a lot of volcanism going on there. We see some very old volcanoes on Mars. How do we know that they're old? We look at the craters. Remember, the older surfaces have more craters. So some of these volcanoes have craters on them, on the slopes of the sides of these volcanoes. Like here's the caldera and the lava flow, but these are all craters from impacts that happened after that volcano erupted. So that dates them pretty early on. Because remember, we said most of those impacts happened in the first billion years. So the volcanoes were active at the same time on Mars. Okay. Mars also is home to the largest volcanic mountain, the largest volcano mountain, the largest mountain of any kind, really, in the solar system, but it just happens to be a volcano. We call this mountain Olympus Mons. So Olympus Mons, remember we like to name things in Latin, but that is just Mount Olympus, right? The mountain of the gods. Oh, and I misspelled that. It's spelled the same way as I spelled it before. Olympus. Okay, Mount Olympus or Olympus Mons, biggest mountain in the solar system. This thing is huge, y'all. This picture on the right here, this is Olympus Mons on the top. These other mountains, that is on Venus. That's Venus's tallest volcano. And this right here is Mount Everest. So if we compare Olympus Mons to the biggest mountains on Venus and Earth, it just completely dwarfs them. It is about the size of the state of Arizona. So really big thing. We think it was active relatively recently, maybe as recently as 100 million years ago. So that's a lot different than some of the others that might be 3 billion years old. This might have been active as recently as 100 million years ago. There could be volcanoes that are still active on Mars, but we have not seen an eruption. All right, so next we have Venus, the queen of volcanoes. Venus has the most volcanoes of any planet, the most volcanism of any kind, lots of different volcanism, all kinds of stuff going on there, all kinds of different types of volcanoes. I'm not going to go into the different kinds of volcanoes here, but if you take a geology class, you'll learn about the different types, the pointier ones, the flatter ones, the thicker lava, thinner lava. It's all going on here on Venus. There are also flatter lava flows like we saw on the moon coming up from cracks in the surface of Venus. The lava was probably extremely hot because it seems to cover basically the entire surface. And this is the best candidate for having active volcanoes after Earth would probably be Venus. But again, we have not seen an eruption since we've been watching Venus with modern instruments. Um, but it's still possible that it could be active today. Um, this is an artist's interpretation of what it would be like to be on the surface of Venus, with these lava flows. These would be dried lava flows these days. This comes from radar data that we've taken of the surface. I have posted a couple of extra videos for you to watch on Venus. They're short, but they kind of show some of that radar data and how you can see the surface of Venus with through the clouds, I guess, so to speak, with radar. One other thing I want to show you real quick before we leave this video is you can look at Google Space. And with Google Space, you can see some of these features and others that we've talked about. There is Olympus Mons. So we've mapped the entire surface of Mars from satellites that go around it. So you can see these strips here. Can't really point to them, but the strips are just from different satellites taking pictures as they orbit around the planet. But you can see how big Olympus Mons is there. You can volcanoes, surfaces, like if you look at the bottom of Mars here, you see a lot more craters. You see more volcanoes up in the top part here of Mars. So you can play around that Wave Canyon. Where is it? Okay. So it says it's there, but I'm not seeing it really. So you have this big scar here, some of it here. Okay.